In this particular lesson, we will be introducing the concept of machine learning and why machine learning is important and some of the applications of machine learning. Now, what exactly is machine learning? Machine learning is an artificial intelligence which explores the construction and study of algorithms that can learn from and make predictions on the data. So you see, so far in our industry, until the invention of technologies like artificial intelligence or machine learning, the machines were going through a predictable system. Now, what I mean by a predictable system is that you write a piece of code and then you ask the machine to run it. And all the machine does is just follow the code step by step and execute the instructions. Well, that is called the predictable way of doing things. But in the modern era, this is not at all sufficient to solve complex and massive problems. So when you look at the world as a whole, the problems that we are trying to solve these days are much more complicated than we had earlier. To consider a very simple example, let's think about natural language processing or NLP, right? I'm quite sure that all of you could have either used the Apple's personal assistant called Siri or your Google Now, which has the voice functionality. Now, how can you train a system which can detect the thousands of dialects from millions of people among noises and understand that what the person means? Now, this is not possible through a systematic or a pre-programmed way. If a machine wants to achieve something like this, then it has to learn. And that is exactly what we discuss in machine learning. Now, using a set of algorithms and some examples and observations, the machines are able to learn on their own, and this technique is called machine learning. Now, the learning that is being done is always based on some sort of observation or data, such as examples, direct experience, or instruction. And many a times we will be using a combination of all these things. Machine learning focuses on the development of computer programs that can teach themselves to grow and change when exposed to new data. So the idea behind machine learning is to create a world where the systems are self-sufficient to make decisions. And machine learning or artificial intelligence is not here to replace human intelligence, but they are to coexist and solve problems in a better way. Now, even though you may feel that the term machine learning is a very new set of entry to the market, it is not. The term machine learning was actually coined long back in 1959 by Arthur Samuel. So what Arthur Samuel has written is that machine learning is the subfield of computer science that gives computers the ability to learn without being explicitly programmed. And that is what we have discussed just now. Now, Tom M. Michel provides a more formal definition which says a computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience E. So the core idea behind Tom's definition is that any computer program should have some observations or data to learn, and over a period of time, the experience should grow. So when you say improving the experience, it is actually a measure of the accuracy. So whenever we think about machine learning, you will be naturally wondering that if machines have to make a decision, how do you validate whether that decision is correct or not? Well, in most of the cases, there is no yes and no answer. What we do is that we try to get a marginal error or we try to improve the marginal error. So on a scale, so that is what is meant by improving with experience. For example, if you are looking at, again, natural language processing, maybe you could have developed an algorithm which can obviously read human voice and translate that into text. And probably the algorithm may not work all the time, but you must have a sufficient level of acceptance, I call it. So let's say if 85% of the time the algorithm is able to translate speech to text, then that means the threshold is done and you are happy with the algorithm. So it is a continuous improvement on learning, just like us humans. Now, machine learning programs detect patterns in data and adjust the actions accordingly. So if you have to take an example, I'm quite sure that all of you have used Facebook. Now, in Facebook, you might have thousands of friends and you might have liked hundreds of pages, right? And each of them might be sending an update every now and then. But if you look at your feed, you can see that, you will be getting feed from the friends or the pages you visit quite often or tag in a photo, right? So how Facebook does this is by collectively analyzing your pattern or your behavior. If you are having 1,000 friends and probably 100 of your friends are being active in Facebook, and you keep on visiting their wall, tag them in photos or search for them, then chances are very high that their feeds appear first in your Facebook wall. And same with personalized ads and so on and so forth. So Facebook uses this pattern of end users to display targeted ads and also to display the content of interest. Now, there are plenty of examples of machine learning in the world, but let's have a look at some of them. So the first of them is optical character recognition, and this is pretty simple. It is kind of like a handwriting to text. So, these days, all the mobile phones, right? Especially if you look at the higher end smartphones, they have a way in which you can write something on the screen and they translate that to text. It again uses machine learning. And if you have ever, thought about face detection, it also uses machine learning. So the Apple's new iPhone, the iPhone 10 actually uses machine learning a lot. And if you are an Apple fan, now this is something which you can actually check, right? If you're an Apple fan, now I use an Apple iPhone 7, and very recently I got an update from iOS 10 to iOS 11. And so whenever I get an update, I just check what is there in the update. Now in the update, it was clearly written that one of the functionality that Apple added in iOS 11 is machine learning. So that means the new operating system can better understand your voice, the search, and even your face. If you look at iPhone 10, it has one of the best or more accurate ways of unlocking your phone by detecting the pattern of your face. Now this is done using machine learning. And another example is spam filtering. So have you ever wondered how the email systems are classifying your message, right? So you might be using Gmail or you might be using, Hotmail, and you can see that your messages gets, classified into spam and non-spam. This is again machine learning, and it is kind of collaborative learning in the sense like it's kind of like a type of machine learning in which you can help the system. So what happens is that when you get an email, and you think that it is a spam, there is an option to mark it as a spam. So you tell the system that, hey, if in future any of such emails come and if you find a pattern, then please mark it as spam. And the next is topic spotting. So if you have ever used Google News, it uses topic spotting. So Google News basically displays news from all the major news portals such as the New York Times or BBC or TechCrunch, all these things, right? So when they get news, the system has to identify whether this news belongs to the finance category or the entertainment category or the technology category. This is done using machine learning. It uses a technique called clustering to group similar news items into one group. And obviously, last but not least, like I have been giving you a lot of examples, spoken language understanding. Now, if you look at the application of machine learning, very simple, which I have been talking so far. The one common application is recommender systems. So if you are an avid user of e-commerce, let's say you're shopping from Amazon, right? You see that over a period of time, Amazon starts recommending products to you. So the recommendation engines actually use machine learning to learn your pattern and also match it with other buyers' pattern and recommend stuff. And not only e-commerce, if you are watching shows on Netflix, you get new recommendation. Or if you are a LinkedIn user, you get new connection suggestions. All these are based on recommendation systems, which is again a machine learning. And in business, we have customer segmentation, targeted marketing. In medical applications, we have disease diagnostic. So one area where in the medical applications, machine learning have been gaining a lot of popularity is cancer research. You see, cancer is a disease which is still a mystery to the human species. And cancer, if you look at cancer, there were reports from the ancient Egypt that cancer was there in thousands of years back, and it is still here. And even though we say that symptoms for cancer can be, cancer can be caused by smoking or consumption of tobacco, still there are no hard and fast rules as to why cancer occurs for a person. So in the medical field, machine learning has been using extensively to identify patterns which causes cancer. And also, if you identify a person, whether a particular drug can work for him or not. So the problem with cancer is that you're having a lot of medicine or drugs for cancer, but not every drug will work the same way for everybody. For this, you have to understand the genetics of the person and his history, so on and so forth. So medical practitioners are actually using machine learning to understand patterns which can be targeted by specific cancer medicines. And obviously, if you look at banking, stock market, information retrieval, all these areas, we are having the application of machine learning. What I recommend to the learners is to do a Google search for applications of machine learning and go through this and get a better idea. Now, the biggest question should be how it is done, right? Well, we understand that this is machine learning, but how exactly are you doing this, right? So there are certain phases for every machine learning activity. So obviously, you're going to have some data, and there is a learning phase. Then there is a testing phase, then there is a prediction phase. So what is going to happen? You are going to have some sort of a data. And based on this data, the machine is supposed to learn. So when you say learn, there is something called feature extraction. So say, for example, you want to find out fake banknotes. So let's say you're looking at banknotes, right? So let's say for $1, $10, $100, so on and so forth. There will be legitimate banknotes and there will be, fake banknotes. Now, how do you identify whether a banknote is original or not? So let's try to develop a machine learning system for that. So in that, obviously, the data should consist of the original banknotes and the fake ones. and then you have to extract the features which makes a banknote legitimate or not. For example, it probably might be the dimension of the banknote, the length, breadth and all. It might be the color of the banknote. It might be the weight of the banknote. I don't know. So you extract these features and you match and you give these features to the legitimate banknote and the fake one, right? And then you go to a learning phase. In the learning phase, what you do is that, so you could have created a machine learning algorithm. You feed this data to the algorithm and you say that, hey, if these features match, it is a legitimate banknote. Or if you find these anomalies, it's possibly a fake banknote. So you do this on an iterational level multiple times to make the system learn. So once the system learns, then you go for a testing phase. In the testing phase, actually what you're doing, you will already have the data which you know what it is. Probably you have 100 entries for banknotes, and you know that 50 of them are fake and 50 of them are legitimate. You just feed this data to the system and ask the system to predict, right? And the system will predict, and then you already know which one is fake and which one is original, and you match this with a prediction. And then you define an error margin. So if the system can predict well within the margin, then the system works. If not, you change your iteration, you change your algorithm, train it better, and then make it work. It's pretty much like how we humans learn, right? So how humans learn, we do the same thing. We learn from experience, and then when the situation comes, we apply that, and then we do a self-assessment. So to wrap up, in this particular lesson, we have learned about machine learning introduction, why machine learning, and machine learning application. That's all for this lesson.
If you have any questions, please do not hesitate to raise a support ticket. Thank you.